And I really feel that the study of the brain is one of the absolute exciting frontiers in science and in research and in medicine. You can see a huge corridor going off with 1,000 doors leading from it, all having fantastic amount of information and knowledge, which will eventually be put together so that we will understand more and more and more about the human brain. And I think this, in the future, will lead to understanding better treatments for things like manic depressive illness and schizophrenia, but it will also tell us more about the function of the normal human brain.
Just what new discoveries lie ahead, no one can say for sure. But if our first decades of research are any indication, new findings about the brain promise to be nothing short of spectacular.
It controls every move we make. Its 14 billion cells connect a network of almost infinite complexity, which enables us to learn from the moment we're born. These tranquil folds are the busiest organ in the body, constantly providing us with insight and creativity. Probe the secrets of our mind as we explore the human brain. Next on Body Atlas. I think, therefore I am. This is the home of all human thought and of our consciousness. The human brain is the pinnacle of evolution, the only object aware of its own existence. It's also the center of a complex intelligence-gathering operation that employs the clear window of the eyes, senses to pick out the sounds and sweet airs that surround us, organs of touch crowding into the sensitive folds of the lips, and every inch of the skin. They alert us to a warm wind or the chill of snow, the lightest touch or a stab of pain. These signals are routed along the body's information superhighway, the spinal cord. This bundle of delicate nerves is protected by a spiky suit of armor, the backbone. It leads upwards to the bony helmet of the skull, encasing one small organ that can encompass the whole world outside. Brian and his classmates take this jewel in their crowns for granted. Unlike the body's other organs, we can't easily feel or monitor the brain's ceaseless activity. But it's the key to human success. We've come to dominate the world not by strength or speed, but by the development of this one special organ. We can think in abstract symbols like language and math, and build up knowledge from generation to generation. The power of the brain isn't evident at first sight. Looking like an oversized walnut, it's 3 pounds of soft, watery tissue. The brain's secret lies in its billions of microscopic nerve cells. When we think, minute electrical signals flash between these nerves. It's similar to the electric currents that flow between the tiny transistors in a computer chip when it makes a calculation. But the network of nerves is far more complex. The 10 trillion connections in one brain outnumber the stars in the Milky Way 100 times over. The active nerve cells need a generous supply of energy. This network of blood vessels brings in oxygen and sugar, the brain's fuel. Over a pint of blood flows through the brain every minute. And a continuous supply of blood is essential. Nerves die rapidly when oxygen is cut off. After just a few seconds, some cells begin to shut down. We lose consciousness. After a couple of minutes, the brain suffers permanent damage. Brian's brain requires an energy supply of 10 watts, only a fraction of the computer's needs. Like the machine, his nerve center is wired into a wider network. Electrical energy constantly conveys signals along the spinal cord to and from the brain. But in close-up, nerve cells are very different from electrical wires. There are many gaps for the signals to jump, providing thousands of alternative routes. And living nerve cells can link up to their neighbors, creating yet more new pathways, unlike the programmed route of electric currents in the computer. The nervous system is one of the first parts of the body to form. Only 3 weeks after a human egg has been fertilized, some of the cells develop into a distinct swelling, which becomes the brain and spinal cord. Over the next 2 months, the nervous system develops at an amazing speed. During this time, the brain churns out 250,000 nerves every single minute. These cells move through the tissues of the body to their final destinations. Here, a new arrival is putting out feelers to connect with its neighbors. Over the first 4 months in the womb, the baby's brain produces all the nerve cells it'll ever have. At the same time, bones, highlighted in red, start to form. They protect the vulnerable network of nerves. The top of the skull is made of 8 separate bones, allowing the brain to grow inside. 5 months before birth, 14 billion brain cells are in place. Yet even at birth, vital connections between these cells are missing. Compared to other animals, the newborn human brain has a long way to go to reach its full potential. The wiring of the brain is shaped by experience, as parents and teachers pass on thousands of years of accumulated knowledge. Its expanding network of connections makes the brain grow rapidly. With signals from the eyes and ears, hands and feet, the brain begins to coordinate the young body. By repeating its successes, a child learns hand-eye coordination, the skill of balancing on 2 legs, and even something as complicated as language. By the age of 2, some children can speak 2,000 words. As we learn, we actually change the structure of the brain. All parts of the brain are connected by these bundles of nerve fibers, crisscrossing the interior like telephone lines. Each time we repeat an action or a word, the connection we're using becomes stronger. So as we achieve new knowledge and skills, we literally rewire our brains.